Okay, so we are going to discuss JEE Main 10th April 2019 video solution. Let's start with the first question. The major product of the following reaction is. Now, this is from organic chemistry. If you look at the molecule, it's having an alcoholic group and the amino group. And this compound is reacted with ethyl formate, one equivalent of that, in presence of triethylamine, which will act as a base. Now, what is ethyl formate? It's an ester having a formula HC double bond O C2H5. So, if I look at the substrate, it's having the alcoholic group and the amino group, which can act as the source of the nucleophile. Out of OH and NH2, NH2 is a better nucleophile. If it is a better nucleophile, it will have a tendency to attack on the reagent, and the reagent is having a carbonyl group having a polar C double bond O and delta plus and delta minus. So what will happen is the NH2 will attack the electrophilic carbon center of the ester, and it will kick out the ethoxy as a leaving group. So finally, the H of this would get substituted by the formaldehyde group, which is also called as the formyl group, and the C2H5OH would be the byproduct. Hence, we have the product as CH3, CHOH, CH2, CH2, NH and H replaced by formaldehyde. Hence, the answer is A. Now, second question. It's a question from, you can say, nuclear chemistry. A bacterial infection in an internal wound grows as N-T equal to N0 exponential of T e raised to T, where the time T is taken in hours. A dose of antibiotic taken orally needs 1 hour to reach the wound. Once it reaches there, the bacterial population goes down as dN by dt equal to 5n square. What will be the plot of N0 by N versus T after 1 hour? Now, here you are asked the graph of N0 by N versus T after 1 hour. If you look at the data given, till the time 1 hour, meaning 0 to 1, the bacterial infection was growing exponentially as N-T equals to N0 into e raised to T. So, from 0 to 1 hour, it will be equal to N-T equals to N0 into e raised to 1. But after 1 hour, it goes down as dN by dt. dN by dt, it's a decay, equals to minus 5n square. Now, from this, after 1 hour, what will be the relation of N0 by N versus T is asked. So, whenever graph related questions are asked, you should always talk about the equation and just get an equation in the form of N0 by N versus T, and you will be able to spot the correct answer. So, we have to just solve that for the time 1 hour onwards. So, if I solve it, I have to integrate. I'll take the similar terms together. So, I took dN by n square with a negative sign on the left equals to 5 into dt. Now, integrate this. So, the integration is from 1 hour onwards to time t. So, integration for time will be 1 to t. But now for 1 hour, we know that N-T was equal to N0 into E. So, this will be actually E N0. And after time 1 hour, it is just equal to N. Now, a simple integration. dN by n square is minus integration n minus 2 dN from E N0 to N equal to 5 outside integration T from 1 to T. So, this will be minus of n minus 1. So, it will be 1 by n from the limit E N0 to N equal to 5 into T minus 1. So if I solve this, 1 by n minus 1 by E n naught equals to 5 into T minus 5. Now what I wanted is n naught by n. So I'll just multiply this entire equation by n naught. So n naught by n minus 1 by E equals to 5 into n naught T minus 5 into n naught. Okay. So if I rearrange this, it will be n naught by n equals to 5 n naught T minus 5 n naught plus 1 by E. So this is now plotted on y-axis, T is plotted on x-axis, hence this graph is of the form y equals to mx plus c. Meaning here if you look at the slope, it's positive and there is a y-intercept. So n naught by n versus t with a positive slope, there is just one option and that's option 1. Third question, this is from P block elements, a simple factual question. The correct order of catenation is. Now, catenation is a property which is dependent on bond energy between the similar atoms. And in case of group 14, the carbon family, carbon to carbon single bond has a very high bond energy and CC bond is highly stable. That's the reason it can have the tendency to link with itself and also with other elements to form long chains, which could be straight chain, branch chain, cyclic chain. And that's the reason we have had a lot of organic compounds which are possible. And it's a fact that carbon has the highest tendency to undergo catenation. And in general, if we are talking about catenation property down the group, it always goes on decreasing because the single bond between similar atoms, the bond enthalpy also decreases. So, if I talk about carbon family, it's carbon, silicon, germanium and tin. And carbon has the highest catenation followed by silicon, germanium, tin. This will almost have same. If you look at the other options, carbon is first in this case, but tin order is reversed, hence the answer is first. Fourth question is from P block elements, group number 16, the oxygen family. Again a very simple question. The oxo acid of sulfur that does not contain bond between similar atoms, meaning we have to spot a molecule which does not have the SS linkage. Now, looking at the options H2S4O6, H2S2O7, H2S2O3, H2S2O7. H2S2O7 is a famous molecular formula of pyrosulfuric acid, which is also referred as oleum, which was used in the manufacture of sulfuric acid. And oleum or the pyro always have the SOS linkage, meaning SOS. And if I complete the structure, it will have OH on either sides bonded to S, and the sulfur would be joined by oxygen with a double bond. Meaning oleum is the only molecule which will not have the SS linkage because it has a SOS linkage. In fact, all the other molecules will have the SS linkage. So the answer is 2, but I'll just like to discuss all the other options as well. If I look at first one, H2S4O6, the S4O6 minus 2 is a famous anion of Na2S4O6, which is called tetrathionate anion. And this tetrathionate has a structure in which the sulfur atoms are linked by single bonds. This SS doesn't have any other atom attached to it, and the terminal sulfur have S double bond O, double bond O, double bond O, and O minus, O minus. If I bond the H to it, it will be simply H2S4O6. Matlab it does have the SS linkage. H2S2O3. This is the second oxy acid from the disulfur oxy acid family, and this is thiosulfuric acid. Thiosulfuric acid has a S and S joined by a double bond. This is actually called a thio linkage. On both the sides we have the OH group and the oxygen joined by double bond. So that is H2S2O3. Next, H2S2O4. This is basically the dithiosulfurous acid, And dithiiosulfurous acid have sulfur and sulfur joined by single bond. This is dithio linkage, also called hydrolinkage. On both sides you will have OH and two of the oxygens will be joined by double bond with sulfur. So if you see, the other three options had the SS linkage which are present in the molecule, but oleum doesn't have. Fifth question, this is from electrochemistry. Consider the statements S1 and S2. Two statements are given. S1, conductivity always increase with decrease in concentration of electrolyte. Now, the conductivity K is to be related with the concentration. K is conductance of the ions which are present per unit volume of the solution. K is conductance of the ions which are present per cm cube or per unit volume of the solution. This is how you define. Now, the relation of K with concentration is well known. K is directly proportional to concentration and inversely proportional to dilution. What's given over here? Conductivity always increase with decrease in concentration. It's wrong, because conductivity will always increase with the increase in concentration. It's directly proportional. Let's move to the second statement. Molar conductivity always increases with decrease in concentration. Molar conductivity is the conductance of 1 mole of ions in the electrolyte, and it's famously related with an equation 1000 K by C. So, when the concentration increases, K also increases, but the increase in K is not in proportion to the increase in concentration. Hence, the relation of lambda m and C becomes inverse. So, it is directly proportional to dilution. Two famous relations to be remembered. And now, if I look at the second statement, molar conductivity, that's lambda m, increases with decrease in concentration. Yes, because they are inversely proportional. So, this is right. Hence, now look at the option. S1 is wrong and S2 is correct. Hence, the answer is option 2. Next is a factual question from polymer. It's very simple. Which of the following is a condensation polymer? Options are Buna-S, nylon 66, Teflon, neoprene. Buna-S, this is an addition polymer of butadiene and styrene. Nylon 66 is famously a condensation polymer of adipic acid and hexamethylene diamine. Teflon is also an addition polymer of CF2 double bond CF2, that is tetrafluoroethene, and that's why Teflon is also called polytetrafluoroethene. This is an addition polymer. Neoprene is an addition polymer of a monomer chloroprene. So, Buna-S, Teflon, neoprene were addition polymers, only nylon 66 was a condensation polymer. Next is a question from mole concept. A good question. At 300 Kelvin and 1 atmospheric pressure, 10 ml of a hydrocarbon. Let's assume the hydrocarbon is CXHY, and 10 ml of this hydrocarbon required 55 ml of oxygen. So, oxygen is 55 ml for complete combustion. So, complete combustion of any hydrocarbon will yield CO2 and H2O, and 40 ml of CO2 is formed. The formula of the hydrocarbon is. Now, we can solve this question in a simpler manner by the concept of POAC, which is principle of atoms conservation. So, simply we have to equate the carbons on the left and the right, and as per POAC we can get the value of X. How? Let's see. So, for hydrocarbon the volume is 10 ml. The number of carbon atoms in the hydrocarbon is X. That should be equal to CO2 on the other side having a volume of 40 ml into the number of atoms in CO2 is 1. So this simply gives you the value of x equals to 4. Now x equals to 4 is confirmed, but all the options have a C4 in it. This is not the correct answer because it is only a hydrocarbon. There is no chloride present in it. So the other options would be valid. Now, to get the hydrogen, we have to again apply the similar principle of atoms conservation. But if you look at this, we don't know the volume of the water in this case. What we will do is, we will compare the oxygen and the volumes of the oxygen in carbon dioxide and water on the other side. So, in the first step, what we did is for carbon. Second step, on the left hand side, we have 55 ml oxygen multiplied by 2 atoms in O2, and that should be equal to the 40 ml of oxygen in carbon dioxide multiplied by 2 atoms of oxygen plus VML, I don't know this, I require this, into the oxygen in water is 1. Now if you look at the calculation, it's 110 minus 80, which is equal to 30, and that is equal to the value of V in ml. Now if this is 30, then again apply the POAC for hydrogen. So CXHY mein hydrogen is Y with a volume of 10 ml. That should be equal to water ka volume, that is 30 into 2, because in water the number of hydrogen atom is 2. Now you just calculate what is the value of Y. It's equal to 6. Hence the formula of the hydrocarbon should be C4H6. C4H6. That's option number 4. Next is again the question from organic chemistry. Ethylamine C2H5NH2 can be obtained from N-ethyl phthalimide on treatment with. Now from the phthalimide, the amine is prepared by a named reaction called GPS, that's Gabriel phthalimide synthesis. Gabriel phthalimide synthesis. Now what is the structure of a phthalimide? It is benzene ring attached with C double bond O, C double bond O shared with NH. The reactant given over here is N-ethyl phthalimide, meaning this is replaced by C2H5. Now, the phthalimide reaction proceeds by the reaction with a base. Generally, we use the NaOH or KOH, the alkalis. In that case, with 2 moles of NaOH, this C2H5N and the HH eliminates, giving you a primary amine, and the byproduct of this reaction would be benzene, C double bond O, C double bond O, ONA, ONA, which is a sodium salt of phthalic acid, and that is simply called as sodium phthalate. Now, if you look at the options given, NaBH4, this is a reducing agent. CaH2, it's a calcium hydride. Water will produce and provide an aqueous solution. NH2NH2, this is a base. What we required in the GPS reaction is phthalimide with a base converted into an amine. Hence, the answer to this would be NH2NH2, which is hydrazine, and it's a Lewis base. Next is from periodic table, a fairly easy question. The isoelectronic set of ions is, isoelectronic are those species which have same number of electrons. N3 negative have 10 electrons, 7 with 3. Li plus would have 2 electrons, not isoelectronic. Li plus 2, Na plus 10, again not matching. F negative, 9 plus 1, 10. Li plus 2, not matching. N3 minus 10, O2 minus 10, F minus 10, Na plus again 10. Simply 4th is the option. Next is a question from coordination compounds. The species that can have a trans isomer is, and En is given as ethane 1,2-diamine and OX is oxalate. Now, PtEnCl2. Pt or all the heavy metals which are belonging to 5D series or 6D series, they have the tendency to form a square planar complexes. So Pt would be a square planar in which the ethylene diamine would be linked like this, and we will have 2Cl bonded like this. This would be the complex. So now in the square planar, if I have one bidentate ligand and two monodentate ligand, this two monodentate ligand can never be on the opposite side, because I can't switch over the nitrogen of this ethylene diamine on the opposite side, making an angle of 180 degree, because here the chelation will happen and the angle produced here will be 90 degree, never ever 180. That's not possible. So this would not form a trans isomer because only cis is possible. Cr with En twice OX. Now this is a octahedral complex, and in octahedral complex, if all the three ligands are bidentate, then what will happen is the octahedral is arranged something like this. I have En bonded over here, let's say second En bonded here and oxalate bonded here. Now if all are bidentate ligand, the trans isomer of this complex again is not possible. So this is also ruled out. ZnEnCl2, similar to platinum complex, again not possible. Fourth, PtEn twice Cl2. Now this is the octahedral complex. If I place the two bidentate ligands like this, then the 2-chlorine could lie on the opposite side, giving me a trans arrangement, and the cis arrangement is also possible over here with 2Cl lying on the adjacent side, En and the other En lying like this. So this was the only coordination complex which can have a trans isomer, hence the answer is 4. Next is a question from metallurgy, a very simple question, a factual question. Match the refining methods column 1 with metals in the column 2. Column 1 is a refining method and the column 2 is a metal corresponding to then refining process. First is liquefaction. Now, liquefaction process is used for bismuth, tin, mercury. These are the three common metals which have the refining by liquefaction. So liquefaction goes with tin, that's C. Zone refining is generally employed for metalloids like silicon, germanium. So this will go with gallium as a metalloid. Mons process is famously employed for nickel, and Van Arkel method is for zirconium and titanium, Zr and Ti. So if you look at the option, 1 matches with C. 2 options possible. Zone refining matches with D. So after this D, hence the answer is 4. Our 12th question is from ionic equilibrium. Statements are given and we have to identify which of the statements were correct. The options were given in the combinations. So let's look at the question. First one, the pH of a mixture containing 400 ml of 0.1 molar H2SO4 and 400 ml of 0.1 molar NaOH will be approximately 1.3. So we have to check the pH for a mixture containing the acid and the base. So for acid and base, we will first check the equivalence of acid as NaBa and the equivalence of base as NaNbVb. So for acid, we have normality as 0.1 into 2 because it's a dibasic acid into the volume which is 400. So this will be equal to 80 milliequivalents. 80 milliequivalents. NbVb for the base, it will be 0.1 into 1 because for NaOH n factor is simply 1 multiplied by 400 which is equal to 40 MeQ. Now from the equivalence, we clearly understand that equivalence of the acid is higher than the base, as the solution will have more of H plus and the pH is going to be less than 7. Still we need to check whether it's exactly equal to 1.3 or not. How do we get that? So after this we can calculate the H plus concentration. The H plus concentration is given by NaVa difference NbVb upon the total volume Va plus Vb. So the difference of this is 40 upon the total volume is 800, hence 40 milli equivalent upon 800 milliliter. This is both are in milli, and 40 divided by 800 is 1 by 20. 1 by 20 is 0.05, which means 5 into 10 raised to minus 2 molar. After H plus, we have to get pH. What is pH? Negative log to the base 10, the concentration of H plus. And if I take minus log of this, I'll get 2 minus log 5. And log 5 is 0.7. And the answer would be 1.3, which is exactly matching. Hence, A will be a correct statement. Second statement, ionic product of water is temperature dependent. Ionic product of water Kw is defined as product of concentration of H plus and OH minus. Now of course, with the change in temperature, the H plus and the OH minus concentration would change. With the change in concentration, the product of their concentrations would also change, and hence Kw will change. So ionic product of water is definitely temperature dependent. C. A monobasic acid with Ka equal to 10 power minus 5 has a pH equal to 5. K is a dissociation constant of the acid, 10 power minus 5. The pH is given to be equal to 5, which means H plus concentration would be equal to 10 power minus 5 molar. The degree of dissociation of this acid is 50%. So we have to verify with this data whether the alpha comes out to be 50% or not. Now we know that Ka is equal to alpha square C upon 1 minus alpha. Simply a formula from the Ostwald's dilution law. Also, alpha square C could be written as alpha into alpha C upon 1 minus alpha. The H plus concentration is N into alpha into C. N being a monobasic acid will be equal to 1. So I can just substitute alpha C as 10 power minus 5 and get a relation in terms of alpha, and that's what I have to verify. So K is 10 raised to minus 5. Alpha upon 1 minus alpha into alpha C is 10 power minus 5. This gets cancelled. Hence, we have alpha upon 1 minus alpha equal to 1. Therefore, 2 alpha is 1 and alpha will be equal to half, which means it is 50%. Hence, this is also a correct statement. D. The Le-Chatelier's principle is not applicable to common ion effect. Disaster. This is a wrong statement. Le-Chatelier's principle is applicable for common ion effect. In fact, it states that when there is an ion which is common, then the solubility is always decreased. Because with the common ion effect, the common ion will take away the ions of the other electrolyte and it will shift the equilibrium on the right, thereby the solubility would decrease. So many of the concepts are explained on the basis of common ion effect. Next is a question from organic chemistry. It states major products of the following reaction are. You have a reaction between benzaldehyde and formaldehyde in presence of 50% NaOH and followed by hydrolysis. Now firstly, whenever a carbonyl compound is treated with a base, the base catalyzed reaction for aldehyde ketones are aldol condensation, second Kenny-Zaros reaction, and third is haloform reaction. Meaning whenever you see aldehyde and a base combination, think about these three reactions. Now there were famous conditions associated with them. Aldol takes place when there is a presence of alpha H. In fact, you should always remember that aldol condensation is not given by benzaldehyde, formaldehyde, tertoluraldehyde. And if you look at the reagents, it's benzaldehyde and formaldehyde? Definitely it is not aldol and it is Canizarose, because Canizarose does have 50% of NaOH as the reagent. Now, what is Canizarose reaction? It's a self-redox reaction, and in the self-redox reaction, the aldehyde oxidizes as well as reduces. If it oxidizes, it gives you the acid, and if it reduces, it forms a primary alcohol. But if the aldehydes are different, it's a cross-Canizarose reaction. And between benzaldehyde and formaldehyde, the more reactive will oxidize and the less reactive will reduce. If this oxidizes, it will form a formate salt, which on hydrolysis would change to a formic acid, plus the benzaldehyde will reduce to form benzyl alcohol, which is C6H5CH2OH. Hence, the cross-Canizarose reaction between benzaldehyde and formaldehyde will yield benzyl alcohol but not benzoic acid, benzyl alcohol and formic acid, and the answer is option 4. 14 is a factual question from surface chemistry, a fairly easy question. The principle of column chromatography is. Now, column chromatography is based on differential adsorption. Differential adsorption. It is based on differential adsorption of the substances on the solid phase. What we have in column chromatography is a solid phase and a liquid phase. The solid phase is the stationary phase and it actually acts as the adsorbent. And the liquid phase is the moving phase which acts as the adsorbate. And through the differential adsorption, it will form the columns or the layers which can be extracted. And that's why the answer is option 3. 15, this question from organic chemistry. The major product of the following reaction is. If you look at the reactant, it's an ether and the reagent is HIN excess. If I think about the general reaction, when an ether is treated with HI taken in excess, then 2 moles of HI react with 1 mole of ether, and the 2 hydrogen and oxygen eliminates to give water, and the alkyl groups are bonded with iodine to form iodides. Now, this particular reaction would be possible only if the RO bonds are broken down from both the sides, meaning RO as well as R-O. But if we have a phenolic ether, the famous example of anisole, and even if we have the HI taken in excess, here this particular bond is not broken down because the benzene CO bond is very difficult to be broken due to resonance stabilization. So what happens over here, even HI taken in excess, or if you take 1 mole, the product in case of phenolic ether will always be a phenol and the alkyl will convert to form iodide. So if you look at the question, we have a phenolic ether. This is clearly your anisole, and there is a substituent of a secondary carbon bonded to cyano, oxygen and the isopropyl. So this particular carbon is your benzylic carbon. So with the benzylic carbon, these 2 bonds can be broken down, and that's why here you will get the iodide along with here also iodide. This bond would be broken down, this will give you phenol and this will give you methyl iodide. So finally the product would be a phenol, which is in option 1 and 2, and the iodide at this carbon. So the answer is option 1.